start recording. The online classes will have a time when the lecturer will deliver the lecture live, and they always record it because, of course, sometimes that's going to be at a time when many of our students are working. So you attend the live lecture if possible, and if not possible, then you make sure you review the video. The lectures generally run about an hour in the online classes once a week. But again, you need to consult with your instructor. They should have all that information as to when that will occur right up front when you have access to the shell for the course.
Okay.
You have to be in and do 4 daily checkpoints a week to get attendance. Obviously, you want to do all 7 because that's an extra, 60 points over the course of a mod. And then there'll be the usual structured assignments, discussions, and assignments and assessments that you'll be doing. So it'll look a lot like what you're doing, but you're going to be doing most of the work on your own. That's one of the reasons that we try to have the availability of an instructor for tutoring during the week. And I've done that. I've spent time with students tutoring them through messy classes online. So that's basically what an online class is. You have to be disciplined. I suggest strongly, I used to tell my students when we could go to campus that when they had an online class, they should just say to their families, I have a class, and come in and just sit at school and do the work. Mm-hmm. Because of course, when you're at home, as you well know now, it's open season on your time. So I would suggest that you treat it just like a regular class, do at least a couple of days where you have a concentrated block of time where your family is told to leave you alone and let you do your work. The biggest problem I think many of our students have is that they do not understand that they have to treat this the same way they treat a regular class. They have to put the time aside and tell their family to leave them alone. That's why I used to tell people come into school. Then you're telling the truth. I have a class. You're just not saying what type of class it is. And they're used to you going. So, they're much more amenable to accepting that. So, but that, that is the important thing is that you must do 4 daily checkpoints a week.
Okay.
And turn in, and many of the online instructors, some of these classes are big. I know I had a friend who switched to IU when I was down in Denver. And she went from we had big classes back then, but she went from having 10 or 15 students to having 40.
Wow.
So the instructors are much more picky about late assignments. Many of them won't even accept a late assignment. Because if you have 40 assignments to grade, you can't afford to have them all come in on the last day of the mod. So be aware that some of the instructors, online instructors, are very, very strict about time. Okay. And get everything. That's another reason to set aside the time and just do the work each week. But that is the best advice I can give you on dealing with an online class.
Okay.
Okay. So it's a little different than the online classes we're doing that should be in-room classes like this one. Um, and so that's just what you need to be aware of. All right.
Alrighty, thank you.
You're welcome. And then let's see. Yeah, I don't see any of you have identified as having any other class other than this the classes that John is tutoring, Man 105 and Man 115. So
Okay,
good luck on that. John's real good at those, so I think you won't have any trouble.
okay. Yeah, I've had him for a couple classes before too.
Yeah, his classes seem to go pretty well. All right, pull this back. All right, now let's talk about portfolium. Our assignment this week is a portfolium assignment. And what this means is that you guys need to register. Jennifer's already done that. Thank you, Jennifer. I appreciate that.
You're welcome.
So the rest of you need to go ahead and get registered into Portfolium for this class. I cannot see the assignment. I'd love to know what your assignment is so that I can potentially help you with it. This involves looking at statistics and correlation. I would like to touch on that topic briefly. Since I don't know what the actual questions are, I can only make some general comments, but I'd like to touch on that when we have more people in.
When I went into it earlier, I took a copy of it and I pasted it in my notes, the whole prompt and everything. And I saved that in my notes. I could screen share that if you would like.
I would love to see that. Let me set up screen sharing so that we can all do that. Stop it. Anna, you're on. Great.
I've been on for 10 minutes.
Okay, good. I didn't see any notice. Okay, Jennifer, you can go ahead and share.
Okay. Just got to get back to the right screen so I could see. This toggling screens, I should be better at it by now. Okay, screen share. Notes. I think this is the right one. We'll see. Okay, can you guys see it? This Portfolium says at the top.
It's still loading.
Okay.
Here we go. Aha.
Okay. So this was, oh, I guess I can go back to that screen. Oh, sorry, I just lost the screen. Let me go back. Can you guys still see it?
Sure.
Okay. See if my cursor, okay, the cursor will work. So I just basically copied and pasted the whole thing, not just the prompt. So if it'll let me scroll down, I'll get down here to the actual prompt.
You just has Word or OneNote? Jen?
Yeah, I do. I use OneNote a lot like that, especially like on my daily checkpoints. They have so much information that they cram in there that I just copy and paste it into OneNote. And then that way I can use it for reference.
Oh, that makes
That's a
sense.
good idea.
It is.
Okay, here's the prompt.
Okay. Imagine the insurance company where you work wants to create a community engagement project to bring awareness to the increasing problem of gun violence in the community. Gun statistics, create a minimum 8-slide presentation with at least 2 references where you share your interpretation of the data. Now, let me make one thing clear. There are a lot of opinions, especially around this particular topic. Your opinion is not going to be graded, only your presentation. I don't really, I mean, I obviously care about a lot of aspects to this problem, but I don't care for the purposes of this class, what your opinion is, and that will not be interfering with or influencing your grade. So I just want to make that clear.
Can you repeat that again?
I will not grade you on your opinion, only on your presentation.
Okay.
Okay? Your
Okay.
opinion is your business. You have the right to have whatever opinion you want.
Right.
So,
Okay. That makes more sense.
okay. All right. Okay, so part of this boils down to, I was looking at that and saying, okay, where's the statistics coming in? So you're getting statistics, information, okay? And then a correlation either of sales versus gun related or gun incidents based on a history of violence. And I'm assuming the history of violence of the people involved in the gun related incidents here. So what you're doing is looking and seeing if there is a correlation. Now, we talked about that. The correlation assessments are done using dot plots generally, because you have two variables. In this case, you've got gun sales and gun-related incidents, or the gun incidents and history of violence on the part of the perpetrators. So you have two variables. So one would be an x-axis and the other the y-axis. You can choose whichever one you like. And then you can go back and look at last week when or so when I put up the graph, the different kinds of graphs. One of those was a dot plot, and you simply take your numbers or your information and plot one sale, say number of sales and gun-related incidents. Just plot whatever data point you have and look at the scattering of those plots. These are not the dot plots, the scatter plots. These are scatter plots that we're looking at. And remember, you can see trends or not. Now, just because something is correlated does not mean that one causes the other. There could be some third or multiple factors that make it look like these things are related without being caused. My favorite example being, as I said in class the other day, the correlation between the price of a slice of pizza and the subway fares in New York. I mean, there is a very clear linear correlation between the two. But the concept that pizza prices will cause changes in subway fares is ludicrous. That's an extreme example, but we have a problem in our society with understanding that correlation is not necessarily causation. So I just want you to keep that in mind, because what you're doing here is just looking at that correlation. Causation is, in this particular topic, is a complex sociological issue, which we will not be obviously getting into in a class like this, but it is something that's been in the news quite a bit. So Jennifer has this. I don't know that everyone will have the same thing. That's part of the problem. So each of you will need to go ahead and get into the portfolio, get registered, and see what your problem is. Okay? Comments, questions?
Yes, I have a question. So when you say
Okay.
register with Portfolium, is that something, I already have a Portfolium. I've done Portfolium before. Do we have to just register for this assignment?
Yeah, for this class. Yeah.
Okay.
Yeah.
Okay. And that's just is it under that assignment where we do it?
It ought to be in when you're trying to get into Portfolium, it should make you do that.
Right.
Jennifer, what was
Okay.
your experience?
I found when I clicked on the assignment for this week, it says in the shell under where all of our assignments are listed, and I just clicked on start here or something like that. It's under, it says Portfolium, and then it says for instructions or start or something like that. It's in that first paragraph, and it's a link.
Awesome.
And it just opened up to the Portfolium that I already had for other classes.
Okay.
Yeah,
Cool.
that's the way it's supposed to work. And the frustrating part for us instructors is that we have no way of seeing what you have to do until you
Right.
either tell us, as I've just asked Jen to do, or turn it in. Then I have to go back and say, okay, what are we working on here? So
Yeah,
seeing
and in
this, I have an idea of what I can expect from Jennifer's assignment.
And I
And
think
so,
in previous
ahead.
classes, sorry, John, I know how does email our assignments to him too. Do you want us
Yeah.
to do that?
That would be useful.
Okay.
Then I can store them all here and have them a chance to look at them a little more in a
Okay.
little more detail. As I said, the other thing is that if I know what you're doing, then I can more intelligently answer questions.
So on the rest of that, it says for the project, you'll need to research gun statistics and create a minimum of 8-slide presentation.
Mhm.
Do we need graphs on each one of those slides, or can we do like one slide with a graph and the next slide with the explanation on it?
Yeah, you can do it that way.
Okay.
This is something that is always an issue with PowerPoint. What you don't want to do is put too much information on a PowerPoint because you'll just first off, you can't read it,
Mhm.
or the audience can't, and they spend more time trying to read what you've written than listening to what you're saying.
Yeah.
So that's one of the reasons I often will avoid using PowerPoint at all in a class. Because the other thing I've found is especially when PowerPoint first became available, teachers would simply put this stuff up and read them to the students. Well, you can read, and they should only be a prompt for the person making the presentation. Now, you're obviously not going to be presenting these in class, but they should be a prompt. And they should allow you to take off and discuss other topics that are related to the information on the PowerPoint. So yeah, keep them simple.
So are we recording them for like a presentation, or are we just submitting what we do for
You're
the
submitting
PowerPoint?
the PowerPoint. Okay. So here we are. So you can see that I don't necessarily have a way of finding anything, as you know. So I will look forward to receiving those emails. All right. So we'll get started on that. Nathan emailed me that he was going to be a bit late, so he will be on later. So we have what's going on now. So let's take a look at this week's discussion. And in it, your prompt is here. And the idea is that you're going to be discussing the ways graphs will make a more impactful statement to your team. I have posted some things that I think are useful to know out of my own. Some of it is based on my own experience with working with doing a lot of presentations over the years, but others are based on some obvious research that has been done. The key to effective visual aids is to keep them simple as possible. I mean, sometimes simple is a relative term, but to keep them as simple as possible, and don't overwhelm your audience. Otherwise, they will simply turn off. You can always see when an audience loses it, when people, literally their eyes will roll to the back of their heads because they can't understand what you're doing, and they've lost interest. So the object is to keep it clear and easily interpreted. People will do a mix of listening to you and looking at your material. Some people are capable of doing both at the same time. Most cannot do both at the same time effectively. The myth of the multitasker is something that we have bought into in our society, but anytime you try to do two things at once, you don't do either of them as well as you could if you did them singly. So you want your audience to do more of listening to you, because the purpose of putting up any sort of visual aid is to make a point. And that point is a conclusion that you want your audience to come to along with you. You are always best off helping the audience come to your conclusion on their own. Then it becomes theirs. Even if you have led them to it and made it almost impossible not to come to that conclusion, if they own it, then they believe it. So that's the purpose of effective presentations of any sort. So you want to have them be impactful. You want them to be easy to interpret. And you don't want to make it so complicated that they just decide that they're not even going to pay attention. So anyway, this is a problem I've seen with over the years. Not necessarily, obviously not with any of you, because this is the first time I've seen any of you. But over the years and the many positions that I've held, I have watched people give very effective presentations, and I have watched people give presentations that were absolutely awful. As you know, I'm a chemist by education. And as an undergraduate, I had to take a broad range of chemistry classes. And we had a teacher of analytical chemistry who could put a statue to sleep. He was a really awful lecturer. And he said that his way of presenting, and we had to follow his example in his class, his way of presenting was to write out his entire presentation word for word and then read it word for word in a slow monotone. You can imagine how we slept through most of his classes. That was probably the worst example, but I've also seen people put up visual representations of data that were either just mind-numbing tables of numbers, which had no interest at all. I mean, it's hard to read and impossible to interpret, or so complicated that there was no way to be able to interpret the data. So, you just want to be careful. Keep in mind, it follows the KISS principle. Keep it simple, stupid. Right?
I'll be right back. There's a knock at the door.
Okay. So keep that in mind as you're looking at this discussion. Okay. We're gonna, the assessment here this week Remember, this week's assessment is also includes the career integration thing. We will do an in-class activity on Wednesday. But what I would like to do today is talk about another issue in mathematics, which is the word problem. Okay. So I'm going to bring up something I put together here. We have a lot of problems that you run into in most math classes of the word problem. In the word problem, a scenario is described and you're supposed to put it into numbers and give a numerical answer. So a very simple example is the one here. Sam played more games of tennis on a weekend than Alex did, and together they played 12 games. So Sam played 4 more games. So how many games did Alex play? So what we have here is the first question you ask is what is the answer that they're looking for? They're looking for a number of games. So you want an answer. You either play a game or you don't. So it's going to be an integer. So what you want to know is that. What is the relationship between the idea that Sam played 4 more games than Alex and together they played 12? Well, we have to break it down and turn this English into some algebra. Algebra, once we set up an equation, the algebra is pretty straightforward. Most of these things are pretty easy. So what we want to do is read what the question is. So we look first for keywords, keywords that tell us how things are combined, tell us what the relationship between apparent variables might be. And so what we want to do now is ask ourselves, what do we know? Well, when you see words like add or total or increase or plus or more than, this is the operation of, we're going to see a plus sign in our equation. Minus or reduced or fewer or whatever is a minus sign. Times, product of, like percent of, factor. These all indicate multiplication. And then, quotient, per, ratio, etc. is a division. Maximize or minimize. These are likely to be related to geometry in one way or another. And rate or speed questions is going to be some sort of distance formula. And then time, how long, minutes, seconds, days. Those are the ways those are the kinds of things we're looking for. In the case of this question up here, Sam played 4 more games than Alex did. So if Alex plays X games, Sam played 4 plus X or X plus 4. Either way, remember, it doesn't matter. Addition works in both directions. And together they played 12 games. So if we say that Alex played X games and then Sam played 4 plus X games, then 4 plus X equals 12. So now we just combine our terms. 4 plus X is 4 plus 2X equals 12. Subtract 4 from each side, 2X is then 8, and therefore Alex played 4 games and Sam played 8. 4 plus 4. Together, and you go back and check. 4 plus 4 or 8 plus 4 is 12. So that's probably the right answer. So it's a case of looking at and converting the English into something that starts to look like algebra. I will tell you that sometimes questions will have irrelevant information in them. Okay. A problem might be Sam played 4 more games than Alex did on the weekend of May 9th. That part, who cares what weekend it was? So that's irrelevant information. Don't be confused by the information that's not going to be a part of the solving problem. Many problems have this stuff thrown in as distractors. I hate those because, especially early on, because they just confuse. So, but you will see some of those in your life. So, some of the wording can be tricky because it'll be maybe the reverse thinking. If this one of the tricks, the reverse thinking here might be on the weekend, Alex played 4 less games than Sam. That's the reverse. It'll give you the same exact number, same exact answers, but it might be reversed in its wording. So the example here, Sam has $2 less than Alex. How do we write this as an equation? So if S is the dollars Sam has and A is the dollars Alex has, we know that S minus 2 equals A. So $2 less than Alex. It is not going to be S is A minus, no, S, sorry, it's S, Sam is going to have $2 less than Alex. So S will be A minus 2 because this says that Sam has $2. It says both of them actually say the same thing. Sam minus 2 equals A. No, can't be. Sorry, I'm trying to confuse myself. See, this is part of the problem. So we want to make sure that we understand that we're talking about Alex is the base number here. Alex has X, Sam has X minus 2. So what we want to do is to be clear as to how we're thinking through the problem. Okay, make sense at all? No response. All right.
Sorry, I didn't know I was muted still.
Pardon?
It is making sense to me.
Yeah. So the key is to very carefully read the question, write things down, and pick out what needs to be done. This next example, on our street, there are twice as many dogs as cats. Okay. So what is the way to look at that? So if we look at cats as having, X number, then there are 2X dogs. So go back to what is the base? When we see twice as many dogs as cats, we're going to start setting some variable equal to the number of cats and then go from there. So if we, in this case, they're letting D be dogs and C be cats. So the solution would be that D, dogs, is 2 times C, or cats. Okay. So then, obviously, we can't write we can't write an equation here for this because we don't know. Just saying that doesn't give us any handle for determining what the real question would probably want to know is how many cats are there? So you have to know the total number of animals. So this is just an interpretation of a statement. Remember the issue of an algebraic expression? So all you're doing is coming up with an expression. This isn't an equation, okay? Because we don't have any way of solving it. There's no context.
I think that concept there is what I've gotten confused on a couple times on stuff, because sometimes it's not that we're finding the answer, it's more like we're finding the equation.
Exactly. Exactly. So what we're determining first is how to write the relationship between dogs and cats. Okay. And so if we look at that carefully, the relationship here is the dogs are twice as many as the cats, twice as many dogs as cats on the street. Excuse me. So yeah, so we're looking at establishing a mathematical relationship between dogs and cats here. Okay. So let's take a look at a problem that's pretty straightforward. A rectangular garden is 12 meters by 5 meters. What is the area? Well, there we have to have a formula. And the formula, and you'll see this later, the formula for the area of a rectangle is length times width. We all know that. We've probably done that 100 times in our lives, if not many more. So one thing to do is you can draw it out as a sketch. You can sketch it either on paper, which I suggest you do until you get really familiar with these kinds of problems, or you can sketch it out in your head. So we know that the area is the width times the height, or the length times the width. So we simply multiply. We have a 5 meter times 12 meter garden. Generally speaking, and it's certainly not a necessity, we will take the larger number as the length and the smaller number as the width. Okay, but it all depends on your orientation. So we're going to use this particular case. Our orientation is the width is this distance across, from geometry, I would call this length. I would call this horizontal line the length and the vertical line the width, but that is only my bias. It doesn't matter because 12 times 5 is 5 times 12 as well. So again, it doesn't matter which one you choose. Okay. So we went through the calculation of the number of tennis games played by Sam and Alex already, and this sort of shows how we set that out. So we already decided that the number of games Sam played, or S, is going to be the number of games Alex played plus 4. So together we know they played 12. So what we do is we substitute. We know that Sam is Alex plus 4, so we simply substitute A plus 4 into the second equation, So we get A plus 4 plus A equals 12. So we already went through that. We know that Alex played 4, and therefore Sam played 8. Make sense?
Yeah.
So let's make a little more complex issue here. And this is, let's assume that Alex and Sam are carpenters and they make tables for a living. So together, if they work together, they can make 10 tables in 12 days. Okay. If Alex is working alone, he can make 10 tables in 30 days. So how long would it take Sam working alone to make 10 tables? Now, let's do a little logic on this first. If working together, they can make 10 tables in 12 days, but Alex working alone can make 10 tables in 30 days. That means Sam must be able to make tables faster than Alex. Does that make sense?
Mm-hmm.
Between the two of them. So if we use Alex's work rate and Sam's work rate, so we know that 12 days of their work, each of them, 12 days will produce 10 tables. So 12 times Alex's work rate, which is tables per day, and then 12 times Sam's work rate, which is also tables per day, is going to add up to 10 tables. Because we've got 12 days times Alex's tables per day and 12 days times Sam's tables per day. So we also know that if Alex has to work alone, he can produce 30 tables or 10 tables in 30 days. So 30 days times Alex's rate of tables per day equals 10. So what we want to do is to ask how long it would take Sam to make 10 tables. So if 30A equals 10, Alex's rate per day is 1/3 of a table per day. Okay, 10 tables per day times Alex's rate for 30 days, we divide both sides by 30, and this is 1/3. So Alex's rate is 1/3 per day. So 12 times A, or 1/3, plus 12 times Sam's rate is going to add up to 10. So we have, next, we solve for this. We simplify this first multiplication. Remember, PEMDAS says we do our multiplication first. We have 12 times 1/3. So that's 4. So now we have 4 plus 12 times Sam's rate is 10. Subtracting 4 from both sides, we get 12S equals 6, dividing by both sides. So Sam's rate is half a day, is half a table a day. We already agreed that, hi Nathan.
Yes, sir, are you?
Welcome to class. You'll have to review the first hour or so later at the afterwards, because I talked about what we're going to do and I talked about the portfolio. Okay.
Okay.
And now we're working on word problems. So if so we've just figured. So if that's the case, then Sam's rate is half a table a day, so 10 tables would take Sam 20 days. Okay. So we were asked to figure how long it would take Sam to make 10 tables. We know that first off, Sam's work rate is going to be X number of days times half a table per day. Okay. That makes sense to everyone?
For the most part, yeah. It makes sense. I think I should practice a couple more like that one to really catch on fully.
We'll be practicing some more later today, okay, after we take our break. Let's take a look at another one. And then we'll take a break. Jenna is training hard to qualify for national games. She has a regular weekly routine. She spends 5 hours a day on some days and 3 hours a day on others. If she trains 27 hours in a 7-day week, on how many days does she train for 5 hours? So we have the number of 5-hour days we're going to call day, and the number of 3-hour days we're going to call E. If there are 7 days in the week, the number of 5-hour days and the number of 3-hour days has to add up to 7. Okay. Now, she has, that 7-day week is only important later on. So this is a part of a problem. She trains 27 hours a week with D 5-hour days and E 3-hour days, then 5 hours times the number of 5-hour days plus 3 hours times the number of 3 hours per day. 3-hour days is going to equal 27 hours. So we want to know how many 5-hour days. So if D plus E is 7, we know that E is 7 minus D, and we can substitute that in. 5D plus 3E is, okay, this is a mistake. This 27 here is wrong. Let's just kill that right fast. I missed that when I was doing this. Is 5D plus 3 times 7 minus D, 27. We know how to simplify this using this expression here using PEMDAS. So we first off clear out the parenthesis by multiplying 3 times 7 and then 3 times minus D. So we have 5D plus 21 minus 3D. That's still equal to 27. So we subtract 21 from both sides. 5D minus 3D equals 6, so 2D is 6. So D, the number of 5-day exercises, is 3. 5-hour days is 3. So that means that there must be 4 3-hour days. So if we add those up, we've got 3 times 5 hours and 4 times 3 hours, we get 27. Okay. So does that make sense how we set this up?
Yep.
Writing down the relevant information is important. If you write down the information in there, you can usually see what's the important stuff. But this is the key, the relationship between 5-hour days and 3-hour days. Okay. So let's go ahead and take about a 10-minute break. And we'll come back at around 10 after.
Okay.
All right.
All right. See you in a few minutes.
Okay.
I think I might have scared my district manager. I say this because he called me while we were in class. That's why my picture disappeared. I was like, hi. It's like, hi, is this Anna? I'm like, yep. And you must be the district manager. And he's like, yep, I'm just calling to see if we can start scheduling things for you. And I'm like, for a different store, figure out the schedule. And I'm like, well, I'm in class. And he goes, oh, so sorry, so sorry. Thank you again. Thank you. Call me back on this number when you're done with class. Okay. Oh. All right. I'm gonna go.
Okay. Let's see, is everyone back? Harley had to drop out, so she won't be with us the rest of the day, I suspect.
Yeah, that's what it sounded like. She was having kind of a hard day.
Yep. The problem with having roommates sometimes.
Yep. I think right about now, no matter who people live with, they're getting on each other's nerves.
Yeah. This is the case. So what I was planning to do is go through this and then we'll do some example problems. And then turn everybody loose to work on things like their portfolio, get started on the portfolio assignment,
Okay.
since it's going to involve some research, I think, for everybody. So how are you this morning, Nathan?
Yo, I'm doing good, sir.
Good.
How y'all doing? Oh, I see Angela back. Hey, are you being
Hi.
Angela?
I'm okay, yes. I actually wasn't sick. I just had things with my daughter, but I'm okay. Thank you.
I'm starting to get really bad spring fever.
Yeah, when it's about to convert to summer in a hurry.
Yeah, well, and this is my first spring not up in the mountains for like, I don't know, 17 years. And before that, I lived out in the country in Kansas. So like the city is starting to really get to me, you know, like I would do anything to just sit out in the mountains with nothing but nature around me.
That sounds
Instead, I live in Greeley, so I hear gunshots every day and
Oh,
sirens all the time.
right. Yeah, no, thank you.
Well, it sounds like your portfolio assignment is right up your alley then.
Right.
That's what I was thinking. I was thinking about just looking up the statistics for Greeley and their gun violence. But the scary part is I hear gunshots almost every day. The other night it was quite late and it was rapid fire, you know, several in a row, and no sirens at
Wow.
all, you know? So
Greeley was that bad. That's how it was when I lived in Omaha, the neighborhood that I lived in. The street we lived on was nice, but the right down the street there were some apartments that were just terrible, and we constantly heard that.
yeah, that's
So
how it is.
scary.
And I don't know how familiar you are with Greeley, but we're right by Bittersweet Park.
Mhm.
And Herman's lived here since the house was built in 1960 and he bought it brand new.
Wow.
So like he said that there didn't used to be that, you know, but it used to be a pretty nice neighborhood, you know, but it just happens.
Because that's how the neighborhood I grew up in was. Like when I was young, families wanted to live there. Everybody, started coming there, and then it just went downhill. So sad.
It is. It really is.
Yeah, it'd be nice to work on ways to reverse that, wouldn't it?
It sure would.
Yes.
Honestly, I can't wait to this pandemic or to get over so I can go back to the campus. I really miss it.
Yeah. Yeah.
Yeah.
Hopefully we can start doing things more. When I was in Omaha, though, you guys, it was so weird. They're not doing anything like here. Like I would see like older people with masks on, but in the stores, nobody had masks on, and like everything would just seem normal there. I meant to look up what their statistics are there for it, but it's like here, everybody has masks because we have to. And there, they don't have that, so it's like nobody does. It's weird. I was like, well, this is different.
My daughter in Kansas said kind of the same thing. She's like, even though a lot of places were shut down or on like different schedules, it's not like what it is here.
Right, being a lot safer here, that's for sure.
Well, we'll see what we'll see what the future holds for that. Meanwhile, let's go back to problem solving. Okay.
Yeah.
So one thing here is that you have to solve certain problems, you have to know formulas. This is an example, finding the area of a square. Now they put in a formula here. The area is pi times the radius squared, meaning pi r squared. And then this little joke here, they're not always round. British meat pies are often little 4 to 5 inch squares of pie. So they don't have to be round. But the area of a circular pie or a circle is exactly that. Pi, this irrational number that can be approximated as 3.14 for almost all uses that you'll see. And then the radius squared. The radius is the distance from the center point of the circle to the perimeter, also known as the circumference, the line that completely surrounds the center. Okay. So if it has an area of 12 square meters, what is its radius? So if we use the area and r for the radius, then we have a formula that says area equals pi times r squared. Okay. So if we can swap sides or not, it doesn't matter. If we divide both sides by pi, then we have r squared equals the area divided by pi. In this particular case, then we take the square root of that number, which is a divided by pi. Following PEMDAS rules, we solve the formula here with the by dividing pi into 12, 3.14 into 12, and then take the square root of that. And again, use your calculators, and we can calculate that as about 1.95. So basically, if we're solving a problem, we need to know what this formula is. If you don't know the formula, you can always look it up online. What is the formula for the area of a square? What is the formula for the volume of a cone? You can look all these up. Okay. So don't hesitate to do that if you don't know what it is. I don't expect people to have memorized all those things from their high school geometry class if they even took it. So if we look at a cube has a volume of 125 cubic millimeters. What is the surface area? So let's make a sketch. A cube is a 6-sided box where every side is a square. So the volume of a cube is, or of a rectangular solid, is length times width times height. Well, if each side is a square, squares by definition the sides are the same length. And in a cube, when we put together 6 of these into a cube, the height is the same as the length of any one side. So the volume is simply the length of the side cubed. Okay. What is its surface area? Surface area means the area of all the faces. We ignore the volume, we just look at the number of faces on a solid. There are 6 of these squares. Each square has an area of length times width, which is the same thing, the side length. So the area of each of these 6 faces is s squared. Since there are 6 faces, it's 6 times x squared is the volume, is the area of the outer surfaces of the cube. Okay. So if we look at V for volume, we know the volume is s cubed. So we already have that. A is 6 times x squared. So we have that. So the first thing we have to do is we know that the volume is 125. Now, we ignore the units when we're doing this. We can't take the cube root of a millimeter. That doesn't make any sense. So we ignore the units and just concentrate on the numbers. If the volume is s cubed, and if we know that s cubed now is 125, we use the cube root of 125. Again, use your calculator, or you can remember from previous problems that 125 is 5 times 5 times 5. So the cube root of 125 is 5. Okay. So we know now that that's s. And then we simply substitute back into the formula for the area, and we get 6 times s squared. S is 5, so 6 times 30. So the area is 150 millimeter squared. Don't be fooled by the fact that the number for the volume and the number for the area are different, and that the area is bigger in the number. This is because we're talking about something that is completely different. Volume and area are only tangentially related, meaning not very close. Okay. That makes sense to everyone how we solved that?
Yes.
You look a little concerned, Jennifer.
Well, I understand it, but then I get lost in the last part of it.
Okay.
So like well, I guess not really, now that I look at it closer, under where you calculate the surface area.
Mm-hmm.
So it does kind of make sense.
Okay. Yeah, the key is to go back and read the problem. We want an area.
Right.
Volume is always in cubic units. Area is always in square units. So we know that the answer is going to have to be expressed since we're dealing in millimeters, we know the answer is going to be in square millimeters.
Okay.
Okay. So that's something to keep in mind, and maybe write down right away. What am I after? I'm after some number of square millimeters.
Right.
Okay. So we have the 2 formulas, and these, as I said, formula for the surface area of a cube, you can look that up if you don't know it, but I just, go through the logic. We know that we can see these 3 faces of the cube, and there's the other 3 that are hidden to our view that make up the rest of it. So we know there are 6 of those.
Okay.
And So we know that we can, we know that then that's going to be 6 times the area of each face. So the next thing we need to know to find the area, we need to get a handle on what the side length is. They call it S in this example. You can call it X if you want, doesn't matter. Okay. So
Yeah, it always helps me to label it with something that's gonna click it in my head with what I need.
yeah, so we want side length. So
So
Now
S
we-
is
that.
okay.
how do we relate these two? Well, we need, in order to calculate S squared, we need S. We can get S because we have the volume. Okay, so we just go back from the from this first formula, we figure out what the value of S is and then substitute it in. A lot of times problems like this just require, once you figure out the relationship between between these two, volume and area, once you figure out that relationship, then solving one of these equations gives you the handle to solve the second one.
Yep.
So that's what we're after here. So again, we're being asked for area. So we find what S is this way using the first formula. And a lot of word problems will have this two-step approach. You have to solve one formula to solve the next, but you will always be given enough information to be able to solve one of them easily. And then it's just about substitution after that. And don't get confused when you see numbers that you think, well, that can't be right. That's too big. Remember, 150 square millimeters has nothing to do with 125 cubic millimeters. Okay? Volume and area are obviously, any volume, any solid object has a surface area as well as a volume, so they're related, but they're independent entities. Okay. Any other question? Angela, Anna, you on?
I'm good.
I'm good.
We're so good.
Okay. Okay, let's, so a lot of times you're going to find these kinds of problems come one way or another, and you probably figured it out, which is calculating a paycheck based on hours worked when you have differential rates. It gets a little more complicated. When we lived in Australia, I was working on a job that I sometimes was working holidays or Sundays, and but anytime after normal working hours, I was receiving time and a half. On weekends, I received more. On holidays, I received as much as triple time. So it's a complicated thing to figure out, except that if you break it into pieces, then you know what you have to determine. Joel, here in this example, guy works at a pizza parlor, and when he works overtime, it's 1 1/4 times the normal rate. So if he works for 40 hours at the normal rate of pay and then 12 hours at overtime, and he earns $660 together in that week, what is his normal rate of pay? Well, one way of looking at normal rate is 40 hours times times X, if you will, his normal rate, plus 12 hours at 1.25. A quarter is a fraction of, the fraction 1/4 is 0.25. So it is 12 hours at 1.25 rate. So that adds up to $660. So what we have, now here he's got this example uses N as the number of dollars per hour that he earns. So he gets 40 hours at N per hour, which is 40 N. Overtime is 1.25 N per hour, 12 hours at 1.25 N, okay, equals 15 N, so 12 times 1.4 N, or 1.1 and 1/4 N, that's 15. 1.25 times 12 is 15. So together he gets 660. So we just plug these numbers in. We know that if we add this and this, it'll add up to 660. So we've now
I
done,
thought
we've now
1/4
done,
was
go ahead.
I thought 1/4 was 0.25 because
That's-
that's a quarter.
What did I say? It's one, it's
1.4.
1 1/4. Yeah,
1.25.
1.25 is 1 1/4, yes.
Yeah,
Sorry about that.
that's what I wrote down that you had said. So
I know at one point I said
Yeah,
1.4, so anyway, but if we add that, 40N plus 15N is 55N. So if we then divide both sides by 55, we get $12 an hour. Okay. So then he gets $15 an hour for his overtime, which is 1 1/4 times 12. So he gets $15 an hour overtime. Okay. So we can check on this. So the question was, what is his normal rate of pay? Well, we've answered the question, $12 an hour. But we go back through and now plug this number back into our formula to see that it adds up. And we find out that it does, $660. Okay. Now, something that we had before was some compound interest issues, compound interest questions. So we will have, so question here is how much, if we put $2,000 in the bank at an annual compound interest rate of 11%, how much will it be worth in 2 years? Well, remember that we start with $2,000. We have an interest rate, which is 11%. So the formula is present value times 1 plus the interest rate as a decimal, 11% is 0.11, raised to the nth power, which is the number of periods, gives us the future value. Okay. Now, we have to look at the wording, annual compound interest. We do not know how often it is compounded. So they're going to be assuming that it is compounded annually. Compound interest is interest that is paid on interest as well as principal. So in the first year, we're going to earn 11% of our $2,000. And then that will be added to the total. And the next year, we'll get a 11% of the original plus the interest earned in the previous year. That's the way compounding works. It's a way, it is, I heard an economist one time describe it as one of the most beautiful inventions in finance. Because you continually, when you compound interest, you're getting interest on interest. And so it grows much, much faster. Okay. So our present value is $2,000. The interest rate is a decimal, is 0.11. The number of periods is 3. The number of years is 3. And then the answer that we're looking for, how much will it be worth in 3 years? That's the future value. If we had asked How much interest will have been earned in 3 years? That would be a different question, but we're just asking how much that $2,000 has become worth in 3 years. So we plug that in. So we know that the future value is the present value times 1 plus the interest rate or raised to the power of the number of periods. So that becomes $2,000 times 1 plus 0.11, that raised to the third power. We do that calculation on our calculator and we get the future value is $2,000 times 1 point, this long 5-digit decimal. And then, so our future value, if we multiply that out, becomes $2,735.26. In other words, he has earned $735.26 on his investment in 3 years. And if anybody can show me someone that's paying 11%, I want to know where it is. Okay, one other problem here is sort of the reverse. If we put $1,000 into a savings account and the interest is compounded annually at the same rate, then after 9 years, he has his $1,000 has grown to $1,551.33. So what is the annual rate of interest? Well, again, we use the same formula, present value times 1 plus the interest rate raised to the number of periods is our future value. In this case, we know future value and present value, and we know N. It's 9 years. What we're trying to calculate is R. So we have that information. We want R, N is 9, and we have the present and future values. So we set up some formulas. 1551.33 is 1,000 times 1 plus R to the 9th power. Okay. If we then divide both sides, we rearrange it a bit and divide both sides, we know that 1 plus R to the 9th is 1.55133, which is $1,000 divided into 1551.33. It's a good idea in problems like this to keep all the decimal places. I know I've said round it off to 2 places in the past, but in a problem like this, when you're determining an interest rate, you want to keep all of those decimal places, because these are real numbers. These are not approximations. These are real. Okay. So we take the 9th root of 1 plus 1, or 1 plus R to the 9th, and of 1.55. We do that on our calculator by, if we take the 9th root here, that's going to be 1 plus R. And the way we do our 9th root of 1.5513 is to use the x to the y function, except y then is 1 divided by 9. And we'd want to put that in parentheses when we're doing the calculation. Otherwise, it's likely to go wonky on you on the calculator. At least it does on mine. So we'd put that into the parenthesis, which is what they've shown right here. And we solve that and we get 1.05. So remember, that's 1 plus R. So R is 0.05 or 5%. Okay. Now, yeah, does that make sense? Is this sort of sequence of events here make sense?
I think so.
Remember that in any formula, we can solve for the value of any of these variables that are listed here: present value, rate. We can even solve for the number of periods, although that becomes a little bit more of a problem, and we won't be going into that, or we can find the future value. Either one. We can solve, but we need to have information that allows us to know what the other variables than the one we're trying to solve for are. In this case, we knew n was 9, knew the present value and the future value, so the only thing unknown was r. So anytime you have one unknown variable, you can solve for it if you know the values of everything else in the problem. Okay. Let's look at a ratio problem. Okay. All right, so let's, at the start of the year, the ratio of boys and girls in a class is 2 to 1, meaning 2 times the number of boys was twice the number of girls. A year and a half a year later, 4 boys have left the class, and there are 2 new girls. The ratio of boys to girls now is 4 to 3. So there's 4 boys for every 3 girls. So how many students are there altogether now? So what we have, the numbers we have are the ratios, and ratios are merely relationships, okay? So, but we do have that we have a number of boys that have left and a number of girls has now come in that are new. So if we have the number of boys as B and the number of girls as G, then current ratio is, that's now current, not at the beginning of class, but current ratio is 4 to 3. That means that boys to girls is 4 divided by 3. Okay. Okay, so that can be arranged into fix this. 3 boys equals 4 girls. Okay. Boy over girl is 4 to 3. So if we multiply 3 times both sides and then G times both sides, we get rid of the divisor, dividing, and we get 3 boys equals 4 girls. At the start of the year, there were 4 more boys than girls. 4 more boys at the start of the year than currently, and there were 2 fewer girls currently. Let's properly stage this. Okay. So at the start of the year, there were 4 more boys than currently and 2 fewer girls than currently, and the ratio was 2 to 1. Okay, that's where we started. So boys plus 4 to girls minus 2 is 2 to 1, which can be, again, rearranged by multiplying 1 times both sides, so that gets rid of the 1, and then dividing both sides by G minus 2. So we want to know now how many students there all are together, boys plus girls, okay? So if we start with the formula that we just calculated, B plus 4 equal 2 times G minus 2, and we simplify that by getting rid of this parenthesis, b plus 4 is 2g minus 4. So if we subtract 4 from both sides, we get boys equals 2 girls minus 8. Okay. So that is what we have now. Okay, remember, we've now gone to this 4 to 3. Okay. So we've got 3b equals 4g today. So we use this formula next. So if we have 3b, we will, what do we have here? Okay. Okay, Anna, you'll have to watch this later and finish out this. I hope you feel better.
Sorry, guys.
Okay. So now we have, this is a solution. Why do we multiply by 3? Because we know that 3b equals 4g currently. So if we multiply 3b, if we multiply this equation 3 by both sides by 3, then we get 3b is 6g minus 24. So if we remember that 3b equals 4g, then we know that 3b equals, let's see, remember 3b is 4g, and that 4g is 6 minus 24, 6g minus 24, 4, and that 3b actually, 4g, okay, and 4g is that. So we just substitute 3b equals 6, equals, or rather, what have we got? Yeah, 3b. So we've got 4g, 3b equals 6g minus 24. So if we substitute that into the equation that 3b equals 4g, then we have, this is rearranged, but we have 6g minus 24 equals 4g. So we can rearrange that and then calculate, again, subtracting 6 from each side, we get minus 2g is minus 24. We know the answer has to be positive. We can't have a negative number of students. So if we find ourselves looking at something with a negative number, we know we've done something wrong. This is sort of a gut check at the end, right? So then we're dividing both sides by minus 2. In other words, there are 12 girls. Okay. So if 3b equals 4g and g is 12, we know that well, b is 4g over 3. We can rearrange that, 4g divided by 3 on both sides, and then just substitute 12 for g. So we have 4 times 12 over 3. Okay. Again, PEMDAS says you can do addition or multiplication and division sequentially, starting from the left to the right. So 4 times 12 is 48. Divide that by 3, we get 16. So there are 16 boys. We were asked how many students are there altogether. We add them, 28. So we got 12 girls and 16 boys. Does this make sense? Okay.
Yeah.
Now, here is an interesting problem. The product of 2 consecutive integers. Let's parse that. What are the integers? Let's parse that. 2 consecutive integers are basically like 11 and 12 or 2 and 3, 2 consecutive integers. The difference between them is 1. All right, so let's do that. The product is if we multiply them together. Remember, product is a multiplication. Going back up further when we're looking at translating English to algebra. Product means multiply. Okay? So we want to know what they are. We're going to call one of them n. Consecutive integers. Oh, consecutive, excuse me, even integers. I missed that one, boy. Even integers. So the difference has to be 2. Because if you add 1 to an even number, you get an odd number. Make sense?
Mhm.
As I said, read the problem carefully. Okay, so 2 consecutive even integers. So that's going to be n. The second one has to be n plus 2. So we get the product is what we get after multiplying n times n plus 2. So we're being asked for integers. That's our answer. And if we can calculate n, we know what n plus 2 is. We can all add 2 to anything. So we multiply n times the first component of the parenthetical phrase, and then n times the second one. So we get n squared plus 2n equals 168. Now, I won't go any further than that because we haven't gone into solving quadratic equations. You saw a formula that works pretty well, but there is a solver that you can use using this link, which I think you'll be able to link in there when I post this. And the quadratic equation solver gives us 12 and 14 and 12. Okay. And it's minus 14 and minus 12 plus, and so that we get. We know that there are minus 14 and plus 12. That's not quite 2 consecutive integers. Minus 14 and minus 12 is one, 12 and 14 is the other. So we have really, when you run into a quadratic equation, one of the best things you can do is use this quadratic equation solver. We didn't go into that, but I was more interested in how we set this up and expand it to get these numbers. You've got an example here of an architect. Your client wants a room twice as long as it is wide. They also want a 3 meter wide veranda along the long side. Your client has 56 square meters of beautiful marble tiles to cover the whole area. What should the length of the room be? Interestingly enough, the width of the room is L. The total area is A. The width of the room, we know that the width of the room is half the length. So W is 1/2 L. Okay. Then we have this 3 meters that we have to factor in. Okay. We know we're going to take that. We're being asked for the length of the room. Now, let's go back. He wants a 3 meter wide veranda along the long side. So we've got 56 square meters to cover the area. So we know that this is 1/2 the length, twice as long as wide, and that the width then, the area, is going to be the entire length, right? The entire length times the entire width. So we know that this segment is 1/2 of this length, but the total area here is 3 meters, or the total length of, the total width is 3 meters more than 1/2 the length. Are you following my logic on this? Okay. So what we want to do is, if we take this back to this area, the total area here is L times W plus 3. And we know that W is 1/2 L. So the area is W plus 3 times the length equals 56. If we substitute W as 1/2 L, we have 1/2 L plus 3 times L is 56. And we have 1/2 L squared plus 3L equal 56. And if we multiply everything by 2 to clear this 1/2 out, we get L squared plus 6L equals 112. And again, this is a quadratic equation. Simply put it into the quadratic solver. And we find that the length of the room can either be 8 or minus 14 meters. Well, you can't have a negative length. So one of these solutions is not possible in the practical application. So the answer is that the length of the room is 8 meters. I'm not going to give you any of this type of problem to solve, but I suggest you go back when I put this up into, post this as part of the resources for this week, that you just go ahead and play briefly with this quadratic equation solver. Let's see if we can link to it, and if I can share that. Everybody see this?
Yes.
Okay. So here, remember that a quadratic equation, remember I said ax squared plus bx plus c equals 0. So we rearrange that quadratic equation to have a 0 on the right side in our problems. So then we simply plug in these values into this solver, and it gives us the answers. Remember, there are 2 answers to every quadratic equation. So you're going to get 2. And remember also that if we graph this equation, the graph should cross the x-axis at the point where y equals 0. The x-axis, those are the solutions. So we have a couple of ways. This solver makes use of a rather complex formula, which looks daunting until you realize all you do is substitute these things in and solve. Okay? But then that's all this solver does. It does it exactly the same way. It uses that formula. So we substitute these values in and we get the answer. Okay, makes sense?
Yep.
Okay, so we're back here. So we're done with that. I will post this when we get done. So let's go back to course modules. Okay. So do you have any questions?
I don't think so, not yet.
Okay. So it's now almost 11. Let's go ahead and take our second break for about 10 minutes and then come back here. And Then I would like you to get started on your portfolio assignment. Get started on your research. Nathan, you're going to have to register into Portfolio. You know how to do that for this class. Go ahead and call that up. I would like you to copy and paste your Portfolio assignment into an email and send it to me.
Okay.
Okay, great.
Week 3 or 4?
Week 4.
Okay.
That's week 4 is our portfolio. Okay.
Okay.
So go ahead and do that. So let's take our break, and we'll come back and start working on those for the rest of the morning.